Well, hello everyone. On this very rainy Friday afternoon, it's the perfect afternoon to do some feedback. So I have now marked all of your assessments, and you'll get them back, I hope, next week. So just some general feedback. And what I'd like you to do, seeing as you can't actually look at your specific feedback, just have a look at your submission if you've still got a copy of that. I hope you do. And just check which of the things that I bring up now are relevant to you and which ones are not. So let's have a look at what went well. There was a lot that went well. There were many good descriptions of the experiment that you took part in. Some of them were quite detailed. You remembered everything. Also, many of you actually picked up on the things that the experimenter should have done but didn't. For example, including a debrief. You have the right to have a debrief, you ought to have a debrief. Or some of the experimenters needed to mention more things in their consent form so that you knew what was expected. So it was really good that you picked up on that. Many of you also picked up flaws in the experiment. And there was one study on movement synchrony, and I think that the idea was that you were led to believe there was another participant in a different room, but the experimenter said, I'm going to check up on this on the other participant, but he stayed away for like 30 seconds, which made it not believable. So it was really good that you picked that up. Also, if you liked the study, then you showed your enthusiasm, which is great to see. And also, you were good at, the majority of you were good at finding articles that were related to your experiment and describing those briefly. Now this was the good bit. Now we move on to things for improvement. And they're not relevant for everyone, but they occurred so often that I thought it was important to include them in the feedback. First of all, make sure that you do answer all of the questions. So these were the main things to include in a critical evaluation. So all of these points, you do have to include them. You get 1 point for each answer, which is well explained. I mean that if you explain the answer well, not that I've explained it well. But one of the things that was often missing, if something was missing, it was usually this one, quite near the bottom, a different procedure to test the same hypothesis. Now that is important because it links to the methodology literature review. So in the case of the SONA assessment, you need to think, what other method could these researchers have used? For example, in the synchrony experiment, instead of looking at manipulating something in the lab, could we have looked at the same thing in an observational way? Could we, for example, have observed a dance class, how rate people, how synchronous are their movements, and which of those people are actually going on to date one another. It's just a weird example off the top of my head, but you've got to think of a different method. Saying that they should have had a real participant there to make it more believable, that's not a different method, that's just an improvement on the study, which I'm sure some of you meant. So that relates to the methodology review, because that's all about what other ways could they have used, for example, to create priming effects, to test people's creativity. So you really have to think in terms of methods, not just variations of the same method, but actually different kinds of methods. So have a look at your SONA assessment again and see, did you actually come up with a different method? And if you're not sure, or you just want to ask, then please by all means ask me, because that's what I'm here for. Something else that some of you said was, I guessed the hypothesis and this affected my results. Oh, good for you, you guessed the hypothesis. I'm sure the experimenters love that. But it's clever that you worked it out, and that you thought it might have affected your results. But you've got to say, you've got to explain why it is. Why is it that knowing the hypothesis influenced your responses? In what way did you behave differently? And do you think that perhaps this could have affected the validity of the study? Because validity is about measuring what you're supposed to be measuring. So when people are responding based on demand characteristics, so when they've figured out more cleverly what the hypothesis is and they're responding based on what they think the experimenter wants to hear, they want to help the experimenter, you're not measuring the actual phenomenon, but what you're measuring is people's tendency to help the experiment. So it's no longer valid. Something else that came up quite often was the phrase, I couldn't think of anything that could have been improved. But you do have to think about that. That's not good enough. You've got to criticize it. And I think I can understand from your perspective, experiments do look perfect because they're conducted by older year students or lecturers, so they seem perfect. But you've got to try and find something that could be wrong with it, because that's sort of how science progresses, by not accepting each other's views, but each other's experiment, but always thinking about, yes, but. So bear that in mind. Sometimes there was a bit of circular reasoning, like I enjoyed it because it was interesting. Well, interesting is still subjective. So actually what that is saying is, I enjoyed it because I enjoyed it. Like opium causes sleep because it's sleep inducing. So you've got to say, what was it that made it interesting? I enjoyed it because perhaps I learned something about XYZ, or because it related to the other course that I'm studying, or because I've experienced something similar. So give us a reason why you enjoyed it. Need I say more? Some of you still use the word prove, and I'm sure by now you know why you should not do that. So Karl Popper will be nonplussed, as we say. So instead of, prove, let's improve. I'm being silly, it's Friday afternoon, silly time. Moving on. Something else that I think could be an issue is the difference between confidential and anonymous. And some of you said the data were stored confidentially and were anonymous. But that is impossible, because something can either be confidential or anonymous. Confidential means that the experimenter knows your name, but he's not going to tell anyone, whereas anonymous means that they don't know your name either, so your data can't be linked to you personally. Something else, another phrase, that laboratory experiments aren't as reliable as field experiments. What you mean there is valid and not reliable. Because the thing about field experiments is that they, what they're measuring is measured in the place where it naturally occurs. So that means it has a very high ecological validity. But it doesn't say anything about if you were to repeat the experiment, would you get the same thing? It may not be reliable. How to describe a hypothesis and how not to describe a hypothesis. A hypothesis is a prediction. So it is wrong to say the hypothesis was that they predicted, because you'd be saying the prediction was that they predicted. It's also not the hypothesis was to determine X. It would be the aim was to determine. Instead, what you need to say is the hypothesis was that X would be higher than Z. In some of the debriefs, I just had a look at the debriefs that you attached, and in some cases the hypotheses were really well disguised. They weren't easy to spot at all, and they were usually coming under the heading of the aim of the study was blah blah. So if you found it hard to see what the hypothesis was, then have a look at that little phrase, because from there you can probably work out what they were trying to predict. Now, independent variables, they need a name. Everyone needs a name. And they also are not conditions, but they have conditions. So instead of saying the IV was the two ownership conditions, or the IV was whether objects were owned by yourself or by the other person, you need to say the IV was ownership. So ownership, that's its name, with two conditions, self and other. I hope that makes sense, and please let me know if it doesn't. Just a few last things. There were still a few cucumber sentences, but I can draw a skull for the word proof, but if I start drawing cucumbers, then it could be interpreted in all sorts of ways, so I just wrote cucumber sentence. Due to the fact that could be written more concisely as because or as. Now data is plural, it's a plural form of datum, so you need to say data were collected instead of data was collected. It could have skewed the results. Now skew is a word that you use in everyday language to indicate something that's not quite right, sort of skewed. But in statistics it actually has a specific meaning, or should I say in science it has a specific meaning, and it's to indicate the way your data are distributed. It could be positively skewed or negatively skewed, and we'll talk about that in next semester's lectures. But in this case it would be better to say it could have affected the results, and then you explain how it affected them. Dependent is with an E, not with an A. Dependents are children or people you look after, whereas in science we use an E for dependent variable. There's one last thing, something peculiar that I noticed in maybe about 80% of your assessments, and that was this. I got bored after 20 minutes. The task lasted too long. I got fatigued. And I was just thinking about it, trying to explain it, why it is that those experiments bore you. And it's a serious question, I'm not being rhetorical. And I was trying to think back to when I was a student, all that long ago. At that time, my parents had just bought a computer, and it didn't have internet, it was just a word processor. And the mobile phone that I had, also specifically bought because I went to uni, all you could do with that was phone. So I had very little experience with looking at screens. So anything it may sound really sad to you, but whenever I did an experiment on the computer, it was quite exciting. Now for you, from what I could gather, you spent a lot of your time either looking at something on your phone or something on a computer. You're just sort of the computer generation, if you like. And perhaps when you do an experiment on a computer, you expect things to be different, to be exciting, engaging. But of course these experiments often are not, so there's a discrepancy there. And I was just thinking about that, and one of you actually said, I really like that. I put a smiley in the margin. That experiments are not for entertainment, but they're for, for gathering of scientific data, which is quite right. But I wonder whether experimenters would not benefit from having attentive participants. And I just wonder, is it the case that you just have to try and motivate yourself a bit more, or is it the case that experimenters should take into account boredom and try to keep the audience's or the participants' attention, or is it a combination? What should we do? How can we make them get better results and give you a better experience? Is something possible, that combination? So have a think about that and let me know if you come up with something. And anything else in the feedback, please do get in touch, and I'm happy to go through it with you. So for now, I wish you a lovely weekend. I think you're going to have to work on your methodology reviews, but I have to work on my teaching course, so we're working together across the town. Have a good weekend, and I'll see you next week.